Alright guys, my good students, we have a very lovely question here now to look at. The question is 6 times 10 raised to power 22, that is 6 exponential 22, that's 6 times 10 raised to power 22 molecules of an ideal gas stored in a tank at 0.5 atm and at 37 degrees Celsius. Now remember that 1 atm is equal to 1.013 times 10 to the power 5 Pascal. What is the volume of the tank? That is the question. You can take your arrow to be equal to 8.31 joules per mole Kelvin. What is the volume of the tank? That is the question. What is the volume of the tank? Please don't forget it is very nice to subscribe to this channel and also like this video. It's very nice to do that, and it's very lovely if you don't skip any part of the video in order to get the full gist of this class. So let's look at the answer to see what we are actually going to have. Yeah. Alright, now, remember what I said? If you see any question under physics, the first thing you look at is to check the topic that question is coming from and the equation that are already existing in physics that will suit the question, or the formula that will suit that particular question. Now, to actually get things clearly, you have to state, as a beginner, you have to state the ingredients given or the terms given out. So as for quantities that was given in the question, we have the pressure. Pressure was 0.5 atm. Then I'm very sure that the temperature was given to be 27 degrees Celsius. 27 degrees Celsius. Then the molar gas constant was given to be 8.31 joules per mole Kelvin. Joules per mole Kelvin. Then there's another thing that was given, numbers of particles. Numbers of particles or numbers of entity was given as 6 times 10 raised to the power 22 molecules. So this is not number of moles. We are aware of that, because number of moles is simply as the amount of substance which is given in moles, and the unit is not molecules. So anytime you see something so number of molecules, is numbers of particles they're actually talking about. So remember from our amount of substance we did that mole is not just like in per se abbreviation of a molecule. So these are the stuff that was given. Then we are asked to look for volume. We have to look for volume. So I'm going to look for volume now. Now, if you look at the relationship, leave this one first. Let's do this one first. If you check these four stuffs we have here, we discover that this PV is equals to N ROT is still okay for the question, in the sense that your V now will be N ROT over P. It will be possible, but we don't have N. There's no number of mole here. We only have numbers of particles. What can we get? We can get number of moles, because number of moles isn't here as numbers of particles divided by Avogadro's number, which is Na. That will just Na divided by Avogadro's number. That is the number of moles. Number of moles is number of particles divided by Avogadro's number. And Avogadro's number is number of particles divided all over number of moles. So from here, you just get this out. We know that this actually was 6 times 10 raised to the power 22. And we know that Avogadro's number is a constant number, which is 6.02 times 10 raised to the power 23. This is a constant number. We call it Avogadro's constant. So if you run this stuff now, you are going to have a very good answer for number of moles. And that will give us the number of moles to be 0.1 moles. That's what I'm going to have. We solve this out. Sorry about that. We solve this out. I'm going to have 0.1 moles. That's what I'm going to have. 0.1 moles. So we now have the number of moles to be 0.1 moles. So that's already good. Then let's look at the question now. The pressure should be in Pascal. So we use the pressure in ATM to multiply 1.013 times 10 to the power 5. So this is the value in Pascal. So that's the conversion. The temperature should be Kelvin. So we just add 273 to this temperature in degrees Celsius. So we have 300 Kelvin. So we know that P is equal to what? nRT over, okay, we are looking for V over P. Now give us N is 0.1, R is 8.31, then T is 300, then over the pressure is 0.5 times 1.013 times 10 to the power 5 times 10 to the power 5. So if you solve this now, let's see what we're going to have. So this package, let's see what we're going to have. The volume will be equal to something nice. So the volume will be and that will be approximately 5 times 10 to the power minus 3 meter cube, or you can say 4.9 something 10 to the power minus 3 meter cube. That will be the volume. Thank you.